Hello everyone, Mike with Spray Jones, and I'm coming to you with another video, and this one I want to go over why I believe the spray foam insulation, the closed cell 2-pound density foam, is really the future of insulating under slab situations. We're talking concrete floors, whether it's going to be a slab on grade for a house, a barn, a shop, or you're going to have an in-floor heat system, or you just want to do the basement floor. And I think that rigid insulation over time is going to take a very big back seat to the closed cell market. To get into some data, let's take a look at, we're going to break this up into two parts, and this is going to be very useful. If you are building a structure this year and you're going to be doing an in-floor heat system, stick around. And if you're not doing in-floor heat, still stick around, because you might want to think about putting some insulation under to keep the slab warm. You insulate the walls, you insulate the roof. Why not put insulation underneath the slab? And we're going to take a look at a bit of data, technical data, and then I'll switch over and I'll narrate through some videos of us spraying some jobs, and we'll take a look at some details and stuff like that of how we do and what we do and why. So Demilec, which has been bought out by Huntsman is the corporation now that owns them, they produced a radon control document, and we're just scrolling through it here on this video. But what I want to show is not all this scare tactic stuff, but here in the National, NBC stands for National Building Code of Canada. 2010 was the last major official revision that most jurisdictions have adopted. They list, Part 9 is for the Small Housing Act, or small wood frame structures, so a small commercial building or, of course, a house. 913 is talking about protection from soil gas ingress, and that we need to have an air barrier system over the ground. So if you are going to have a concrete floor that is in contact with the ground, you've got to put this air barrier system down, and then they want to provide for the rough-in of a subfloor depressurization system. So we'll just scroll to what they've got, what this looks like. They show a pipe that extends up through the concrete. Here, I'll zoom in closer so you can see. This is in French, but here's your pipe. The pipe has holes in it. The holes allow the gas to get into the pipe, and then you would have a negative pressure. You'd have a draw. You'd have this pipe hooked up to a suction fan. The suction fan would be drawing air from underneath the slab and then expelling it outside of the house. So it's constantly in a depressurization situation. And it would look something like this. Here's an actual. There's the pipe, there's the holes that are drilled in it. This is what we would call radon rock, so it's going to be about a 3/4 to a 1-inch crushed gravel, and then this would be hooked up to a depressurization system. Now, if we scroll to a detail, okay, here we go at the under-slab. If you've depressurized the rock and the gas that's flowing through the rock, and you want to have an air barrier, so you're using 1 inch or you're using 2 inch of closed cell foam to be your air barrier, it doesn't really matter. If you're just using it for air sealing, you might go with 1 inch. If you're needing more for thermals, you'd go higher, right? But what I found with a gentleman from last winter is when you get into a depressurization situation where you're running high volume of air underneath the slab, sucking air from underneath the slab through the rock, and then expelling that air outside, the slab is going to try and breathe at the weak spots. And the weak spot is the slab connection right here to the outside concrete wall. And what ends up happening is you create air leakage down the concrete wall. And so he was drawing air down the wall. He had a batted fiberglass system with poly vapor barrier, and he was sucking air from inside the house space, and it was leaking at the slab connections, and it was coming underneath, and it was causing the concrete wall to frost up excessively. So his solution was to get rid of the bad insulation because he couldn't do anything about the slab, and then get closed cell spray foam like you're seeing here to the wall at 2 inches thick, and then to bring that right down to the slab and concrete wall connection, and to make sure that it was air sealed, and do that all the way around the perimeter. So the spray foam to the wall would stop the frost, but then the spray foam closed cell to the slab connection would air seal the perimeter, and then make sure that the depressurization system is working for only what it's supposed to be doing, which is under slab. This picture here just shows sort of the mechanics of spraying onto the rock. Maybe you're going to do a flash coat. I have no problem with flash coats and then building up the full thickness, but we also try, when the temperature is correct and the humidity is correct, we try to build the full value of the thickness where we can, when we can. So the advantages on this system is going to be the seamless air seal that you get. So if you're doing this conventionally, you'd be laying poly, and then you'd be taping all of the seams of the poly. You'd be taping and caulking the seam to the outside perimeter edge. You'd be taping and caulking the poly around all of the penetrations. So the closed cell foam, again, liquid applied. You don't have to tape anything. There's no seams. There's no letting go of the tape in the joints. And if you had rigid board insulation over top of this, you'd have tens of thousands of feet worth of seams in the board that would need to be taped and sealed. So what do you want? Do you want a liquid applied rigid foam insulation that's going to be seamless, or do you want to try and mess around with this with a prefabricated sheet product of some sort, dimensional sheet product that you're cutting, pasting, and putting into place, kind of like wallpaper? So the reason that I believe that the industry is, the future of the industry is to go closed cell foam, is that the seamless nature is highly desired. Like, if you're truly serious about getting a uniformed air seal from edge to edge and around your penetrations, the closed cell foam is going to be it. Liquid applied, put it over top of the rock, bring it out to the edges, and away you go. However, if you are going to be doing this for a insulation value, so not just an air seal value, but you have got in-floor heat, or you want the slab to be insulated or kept warm, then the closed cell foam is desirable for a couple of additional reasons. Contouring the soil is a huge advantage. With board stock, it sits on top, it's loose, you walk on it, it snaps, it cracks. The spray foam is filling all the little cracks and crevices of the rock, and then when you walk across it, it's not easy to break it because it's in contact with the ground. Furthermore, stockpiling large amounts of rigid insulation on site, getting it, picking it up, having it delivered, having it not blow away, having it stored, making sure that you have enough, no big deal. We got the truck, we got the trailer there, got the hose out, we got the drums out, we just keep spraying, right? Keep adding. And then you've got the ability to roll the foam up the sides if that's what you want to do, if you're going to pour your slab into this. But you've stiffened up the whole entire structure, you've air sealed it. You can then walk across it, put the rebar down, put the in-floor heat lines down, and you're good to start pouring your concrete. So the fact that you can get a lot of product on site quickly and not take up a lot of space is important. We're starting to see guys that are having supply chain problems with membranes and getting rigid and getting enough of the exact product. As long as we've got enough product to do the job, it's no big deal. You're not trying to piece 3 or 4 things together. So I think it is the future of the industry, especially when you come to thickened edge. Here is an example of what I'm talking about, the thickened edge. So you don't have a pile or a deeper spread footing. They've done a deeper thickened, hence edge of the slab, and that is going to pick up the weight of the building. This is common for garages and shops where the slab will be anywhere from 4, 5, 6 inches, and then it will go to 12 or 14 inches at the edge. Now, if you're doing an in-floor heat system and you're going to have your rock profile sloped on the edges so it looks like an embankment, when you show up to the job site, it looks like they're building a berm, because you've got a lower elevation here, sloped soil, and then back up to your elevation for where the slab is. No problem with the spray foam. Now, we do not contour usually underneath for the actual weight bearing portion. You'll notice that even when we're doing a pile system, we'll leave the tops of the piles virgin on unsprayed, and that way there's no interference with the weight bearing portion. So yeah, okay, fine, you know, there is going to be some heat loss through here, but everything else except for the bottom of the footer has been sprayed. And then this would show you an example that if you want to do a frost heave on the outside, that the outside perimeter can be sprayed as well, and then you can come down and laterally away and come out 3-4 feet, whatever the architect or engineer is going to want to call for on side frost heave. So to the people that aren't in the ultra cold climates, what this is just, this is an attempt that as the frost from the cold, this is elevation height here, here's the black dirt level, the frost that's driving down is going to try to get down and underneath the building, and what they're doing is they're placing insulation in between that so that it's going to slow it down or impede it and not get underneath and lift the footings up. So thickened edge is sort of a no-brainer rather than trying to put rigid and tape it and get it to stay in place, and then, you know, is the wind blowing it or those kinds of things. When you're outside and in the open, yeah, putting spray foam on can be an issue in the wind, obviously, but in most situations we are inside of an existing structure before the concrete is going to be poured. Okay, what we are seeing here is a structural floor. It's concrete piles, 12 feet deep. This is a 40 by 40 garage that the gentleman is going to store his antique tractors in. The floor is going to have in-floor heat. The slab does not touch the ground. It comes in contact with the piles. The piles are picking up the weight, and we have to insulate the structure. So you've got all of these 12-inch diameter piles going 12 or 14 inches feet down into the ground. We're going to spray foam insulate it. The way that the weight is transferred is 100% on the piles, and a void form, a cardboard void form, takes up the distance between where the slab, the backside of the slab will be, and the soil. So there will be a 6-inch void between the underside of the slab and the soil. And this is done in areas where they want 100% of the slab weight on the pile system to handle the weight, and none of the weight of the slab is being held up by the soil underneath, okay? Because if the soil shifts or sinks or heaves, then it can crack the slab. So this is why you do a structural insulated slab. So we have a cardboard void form. On top of that void form, the builder has placed 3/8 plywood by my recommendation, because when we're walking across cardboard, we can mark it up, we can damage it, we can fall through, punch through. So to stiffen it up and to make sure that everything is more rigid, we've put down 3/8 OSB. We're then going to put 2 inches of closed cell foam. We're going to leave the very, very top of the circular part of the tube portion of the pile naked without spray foam insulation on it, so that the weight of concrete to concrete can be transferred and nothing in between. We're going to do 2 inches of foam over top of the OSB, and then we're going to roll the foam up the sides on the grade beam, and then he's going to build a shelf over top of that at a later date. This is just on a loop so that we can see over and over again what we've done, and then we'll switch to a video here real quick of us spraying it and also the finished product. This is very, very popular where you have high compressive strengths on slabs and you're worried about ground shift and ground movement, that they will do a structural slab floor where all of the weight of the slab is on the piles. This might not be common in your neck of the woods, but it's very common where we are, because we have got very unstable soil conditions, especially when you're going to have something of high value like tractors, antique tractors being on top of the slab. You're going to want to make sure there's zero shifting in the slab and no problem. So this is one of the most popular ways to do it. It's also very popular to insulate this then with closed cell foam, because they're not having to lay down the rigid on top of the void form and then try to cut and paste and piece the items together. You're going to see here in a minute when we switch videos that it comes out as this one uniform mass, and then they put the rebar in, they tie off the rebar to the piles, and then from there the in-floor heat lines can be run. Then the concrete is poured all on top of it, and it becomes one stuck together cohesive monolithic piece, which is really, really neat. Okay, here we have the almost completed product. You've got the 2 inches of closed cell foam. This happens to be wall type by BASF. The pile tops have been left naked. We have yet to finish spraying the grade beam when this video was shot, but you get the idea. We have now just followed the profile that was there. The pile rebar is going to be bent over. The concrete guys are going to come in, lay down the rebar, and then the in-floor guys can run the lines onto the rebar, and then they can start to pour their 4-inch or 5-inch slab that'll be on top of all of this, and then that will be their finished elevation. So the concrete is going to go down into the piles where these tubes are, and then it's going to be one seamless piece down into the piles, all over the floor. It'll be leveled and screeded and then floated, and then when they're done, their connection points, we will come back once the elevation at the doors and everything's been done. We'll come back for one more trip, and we're actually going to roll the spray foam up the inside of the grade beam and on top. Now you might ask, well, Mike, why didn't you spray the foam up the grade beam now and then pour the concrete into it? And that's a great question, and that's because this is how the builder wanted it. He didn't want to have any interference for that little strip around there. He was very concerned about having a clean bond breaker. He wanted his concrete guys to lay a piece in there that wouldn't have any interference. He did not want us to do it, so I'm like, hey, not a problem. When you're dealing with situations like these, you don't want to be the final say on taking the responsibility for how the slab is necessarily going to behave structurally. So if the concrete guys are saying, leave this area alone, we'll take care of it, don't go here, don't go there, listen to them, okay? You're better off to have a non-structural problem with the slab and give up a little bit of distance on thermal performance than you are to push your luck with the thermal performance and then cause an issue where the slab is going to be cracking or breaking, and they're going to want to hold you accountable. To jackhammer out a slab or make some sort of changes because you made a bad call on where to place something, you don't want to get into that liability-wise. And that's exactly why none of the spray foam is ever going to be on top of the pile connections or the footer connections where they're actually weight-bearing. Now you might ask, what about weight-bearing across all of the surface area? Well, the spray foam under normal conditions of weight load is no worse off than any of the rigid styrofoam that you're going to buy. So most rigid compressible weights are somewhere in the 28 to 30 pounds per square inch, which is more than enough to handle the live load capabilities in residential, commercial, and light commercial garages. Now, if you're going to have a grader shop and a heavy-duty truck shop, I have seen under-slab insulation that is specified at 40 or 50 psi of compressive strength, and that is a unique situation that the 2-pound closed cell isn't going to handle. So you have to ask the questions as a spray foam installer, or if you're the end user and this is going to be your municipal dump truck and grader facility, well then maybe you want to be thinking that closed cell foam isn't the right fit if the compressive strengths are going to be higher. Now, there's multiple ways to deal with that. Is it slab? Is it doweled in? Where's the weight picking up? So there's more than just a hard yes or hard no. You got to ask a lot of questions, but know when to ask the question. What's this being used for? This situation, this is antique tractors, okay? So small little Farmall A's and little John Deeres and little Molines and Olivers and all that sort of stuff. So this is going to have no more weight on it than your standard car and truck situation, right? Which is more than capable of handling with closed cell foam at 29 or 28 or 30 psi of compressive strength. Plus, we're slab, structural slab, so the majority of the weight, 90-some% high of the weight is actually on the piles, right? And you're seeing a work in progress here, folks. Like, it hasn't been doweled in yet to the corners and the edges. The concrete guys haven't done their job. We're just in now as the spray guys. So this is a very good method because it's seamless. We followed the contours. We did this entire structure with 2 trucks in one day. All right. So in one day we had everything. You can see our 2 spray hoses. One spray hose up at the top here and one was off down to the left. And we had everything sprayed out. So 1,600 square feet sprayed in a day, 2 inches. And with setup, tear down, clean up, that's about normal. That's about it for one full day. So in closing here, the closed cell foam 2-pound density can go on the rock. It can be used merely as an air seal and vapor control under slab. It can be used in thicker amounts for the principal insulation for an in-floor heat system, or if you just want, you're not running in-floor lines in the concrete, you just want the slab itself insulated so that you're not losing heat. I had a gentleman that did that for all of his basements. Whether they had in-floor in them or not, he put rigid insulation underneath the slab. Made a heck of a lot of sense, and you'd be surprised, even with spray foam in the walls, how much warmer that basement was because the slab had rigid insulation underneath it. The moral of the story is get your engineering done. If you are a spray foam guy, I'm showing you pictures from Huntsman Building Solutions, which owns Demolec. They've had all the engineering done. They've got 60, 70 pages of all sorts of different details. You pick out the 20 or 30 that pertain to you: thickened edge, slab on grade, or this is with an actual grade beam where it shows the internal side of the grade beam and a spread footing. Get the engineering done. Know your thicknesses. Know where you can and can't or should or shouldn't be putting the closed cell foam. And you've got a wonderful system. It's seamless. It's adhering to the rock. You've got unlimited ability to spray thick values of foam on site. You don't have to run back to the hardware store and pick up more insulation. You're not trying to figure out how to get it all on site, keep it from blowing away. You can have a seamless product that's going to contour around irregularities, and that it's going to have adhesion to the soil. When it does that, you can walk across it quite easily, and then you can be running your in-floor lines, your rebar, or what have you, and you're not snapping off and breaking pieces of it. So I believe that the closed cell foam industry, the spray foam industry in Canada and the United States, I believe that under-slab, it's the future. It's the future of under-slab insulation. We already know it's the future for crawl spaces. I did a separate video on that, on In Contact with Soil, it's called. I'll have to put a link to it on the screen, but you can search that video out in the actual ground playlist. But this is sort of an additional one. I believe this is the future of the industry. So if you're building a house, you're building a shop, you're building a garage, or you're a spray foam guy, market this to your people. This is something that needs to be done. It's safe to do, and it's actually the proper evolution use of the closed cell 2-pound system, because it's not going to be soaking up the water. No additional damp proofing is needed with it. But again, that's all in the engineering. Get the engineering done and you'll have a video on that. People are going to ask about bugs and critters and stuff like that. We're going to address all of that in a very separate, dedicated video that'll probably be upwards of about 45 minutes long to give it proper justice on dealing with ants, carpenter ants, cockroaches, and termites and all that sort of stuff. So watch for that to come out. I've been delaying its release just because there's a lot of information to go over there and I want to do it justice. So I hope this has made some sense to you guys. Lay out in the comments what you think. Lay out in the comments something that I've missed that you want further clarification on. We've been doing this for quite some time. Excellent results, no problems, no complaints. You just got to walk through the steps in the process on how to get it done and how and where and with who. And it's a beautiful thing when you see it done right. So click on the like and the subscribe, click on the share, leave me a comment. We'll catch you on the next one.